Now remember, we have been working with goal seek. Remember that I wanted to solve this problem. I'm going to give my oldest kid €3, second one 50% of what I give to my oldest kid, and so forth. I would like to spend €20 in total. So I make an example calculation. I start with a random value in the yellow cell. I compose my formulas, and this should be 20. So I used goal seek data what if analysis. Goal seek, I said this cell should be 20 by changing the value of my origin of my calculation, which is the value in the yellow cell. And then I come to a total of 20, and I'm going to give 10.66666 and so forth to my oldest kid. That is a goal seek, but I cannot add constraints. For example, what if I don't want to give decimals? I only want to give integers. So I want to give 9, 10, 11, but not 10.666. I can't solve this with goal seek, and that's why we have to jump to the solver. In the course text, you see a theory file that we're going to solve. It's a budget allocation. So a European sales director would like to allocate a marketing budget. We should give the maximum. Germany should get at least 100,000 euros, but maximum 150. France gets half of it, and Greece 25% of the total budget of Germany and France together. The total budget should not exceed 275k euros. And the budget allocated for Germany should be a multiple of 1,000. So if you divide by 1,000, it should be an integer, and there should be no decimals. So how to solve this question? I'm going to enlarge my file a little bit. So first of all, these are my data from the text I just read. I'm going to convert this into k euros. So I'm going to divide that number in the cell right next to it by 1,000. Excel says this is euros. Of course, this is not euros, this is k euros. So I'm going to adapt the formatting of the cell. I'm going to make it a custom format. So I go to custom. I pick this one, and I say quotes space in k euros, close the quotes, and you see in the sample already it says 100, and then I show two digitals after the comma in k euros. I press OK. I apply this also for the cell below, which is 150k euros. I also do this for the maximum budget on row 16. And now I'm going to copy and paste the formatting only into the cells below. So I copy the formatting, which is, I use the brush to copy the formatting only, and I paint it on the cells from Germany till total. So only the formatting has been copied. Now I'm going to make the cell of Germany yellow. That is always the start of my calculation. It's a completely random number, and I'm going to start with 100. It's not a random number, of course, because that is the minimum that Germany should get. France gets 50%. It's B14 times the budget of Germany. And Greece gets 25% of the sum of the budget of Germany and France together. So the total of this example calculation is the sum of the three budgets for the three countries. Now we have to optimize this. So the maximum should be given, and that is the maximum of 250k euros. I'm going to activate the solver. So the solver is in the data tab, where you can here see the solver. If you open the solver, I always strongly suggest to start to fill in the solver top to bottom. If you start filling in variables and constraints without an objective, the solver is going to give some feedback, which is not always that user friendly. So my objective is to give as much budget as possible. So I'm going to set the objective of the total budget. It should be the maximum. What is the variable cell? The variable cell is the budget of Germany. That is not accidentally the yellow cell. There are some constraints. First of all, the budget of Germany should be at least 100k. So I'm going to add constraints. The first constraint is the budget of Germany E18 should be larger than or equal the minimum. That is my first constraint, and I add this one. It's added. I add another one. The budget of Germany should be smaller than the maximum. That is a second constraint. A third constraint, the total budget should be smaller than the maximum of 250k euros. I add this one. There was a fourth, namely that the budget of Germany should be a multiple of 1,000, which means that this number should be an integer. So this number should be an integer, which means it cannot have decimals after the dot. So now I add this one. So you added all of them. Don't press OK, you will get an error message. You have to press cancel to go back. And you see here all the constraints. You have to select a solving method. You always pick simplex to solve our cases. I'll explain in a few seconds what this means. And the options, there you always say that you should not ignore integer constraints. So we said they should be integer, and of course it should not be ignored. So always check if this box is unticked. Ignore integer constraints. You press OK. And I'm going to solve. Now a solver is going to think, and he found an optimum solution. So if you give 133k to Germany, then it is the maximum we can give. It is just below the budget of 250k euros, and we match all constraints. It's larger than 100, smaller than 150. You have here the option to keep the solver solution. If you tick restore to original values, he puts the values back where they came from. And if you tick return to solver's parameters dialog, you go back to the previous screen. So for me, it's okay now. Now, you had the option between a simplex, GRG, nonlinear, and evolutionary. In our cases, simplex is the best one to use. Now, suppose that you have a minimum, but you have somewhere else another minimum that we can find. If you're using GRG nonlinear, he will run through all the different combinations to see if there's another minimum somewhere else that can be found. Now, it's very difficult for us to find these kind of situations. It's mostly when you're using VLOOKUPs and if functions. So for us, you use simplex, which is largely sufficient to solve all our problems. GRG nonlinear is going to look for other optima, in this case a minimum, but it can be a maximum or whatever. And evolutionary is even more precise and will run over all the different combinations possible. I do not suggest that you use this because it might take a half an hour before you found an optimum solution, which is quite difficult when you have this on your exam. And by the way, you won't have a case to solve where you absolutely need evolutionary. So you always take simplex in the solver.